Okay, so we're going to be talking about the other blood bank method. And by other, it means not the tube method.
Gel?
Yep, so gel is the main one. And then there's also the microplate and then the solid phase. Let me find these. Okay, so I'll start with gel technology. And so what happens is you have reagents and gel particles that are pre-dispensed in microtubes of plastic cards. So reagents and gel particles are pre-dispensed. In microtubes of plastic cards. And then what you do is you take the patient or donor sample, and that's added to the microtube. And allowed to incubate before centrifugation. Let me show y'all a picture of what we're talking about when we're talking about these plastic cards. So these are the little gel tubes that that we're talking about. Here's your reaction grading and stuff like that. And I'll show a better one here in a little bit of like a real, a real one. Now, some important notes with the incubation and the centrifugation. It requires a special incubator and centrifuge.
Shoot. Is it, I don't understand. So is it still the same where it's, if it's cloudy, it's 0, or is it just the
No,
opposite?
I'll go over it. I have a real picture of like the real reactions that I'll show y'all in just a little bit. What it would actually look like on an actual like cassette.
Okay.
But this is just like what it's talking about when it's talking about these microtubes. And so I'll show y'all in just a minute what it would look like actually in practicality in the lab. So these the gel technology, the gel system needs a special incubator and a special centrifuge that holds the little cartridges. So it's separate than just the regular one that you'd be using in blood bank or the one that you would use for the tube method. But the reagents are colored the same, so that's nice. Reagents colored the same. And let me I think it's on this one. Nope, not that one. here's a picture of like what the little cassette looks like. And I wanted to point out that like your A and B are still going to be colored the same as the reagents would be in a vial. So your anti-A is still blue and your anti-B is still yellow. So that's kind of nice too. And then you don't have to add any reagents to these. The reagents are already pre-mixed into them. And all you have to add is a patient sample. So whether that be serum or the patient red blood cells, that's all you have to add to them. So that's kind of nice. Now, so here's what the reactions look like on here, and I've got some better ones for that I'll put actually in the notes. Okay, so the reagents are colored the same like I showed y'all. And the gel acts as a filter. So this is what's different than the tube method. The gel acts as a filter. So what that means is unagglutinated cells pass through the gel. And then your agglutinated cells cannot.
Okay, I'm back.
So the gel filter, non-agglutinated cells pass through the cell. Agglutinated cells cannot, which is opposite the tube method results. Well, I guess it's not so much the results as the reactions. Okay, so here is your range of reaction. Here is a 0. So normally your solid button would be like your 4+, but for the gel tube, but when they all precipitate to the bottom or migrate to the bottom, that's a 0. And then a 1+ has mostly at the bottom, but a little bit still coming up. And then 2+ is dispersed throughout the microtube. And 3+ is concentrated more toward the top. And then 4+ is more solidly at the top. And then this is a mixed field reaction where you have a solid line at the top and a solid line at the bottom. So MF is mixed field.
It's moving your picture.
Yeah, that's okay. I'll have it fixed here in a minute. And this can be from
Carrie.
Yeah, it's okay. I'll fix it in a minute.
Sorry. No, my mom wanted to know who that was. I was saying it was Carrie.
Okay. And so mixed field reactions can be from transfusions, stem cell transplants, it can be from someone who has weak expression of their ABO. And then also there's some diseases like leukemia.
So this is why you would do gel?
No. This is it had the 0, 1 plus, 2 plus, 3 plus, and 4 plus, and then it had this MF over here. And I was just explaining that when you have that result, it's called a mixed field, and those are some of the reasons that you would have a mixed field reaction. So those are your different reactions, and then I also have one in color. Sorry, making this look a little nicer. Okay, so here is like the verbal definition of them. So right here you have a negative, so that's that solid, you know, everything went to the bottom. And then your 1 plus is agglutination, red cells in the lower half of the gel column. That COL stands for column. And then your 2 plus right here is going to be red cell agglutinates through the length. So through the length of the microtube. And then 3 plus is going to be agglutinated red cells in the upper half. And then your 4 plus is going to be a solid band of red cells at the top of the gel.
Hold on a minute.
Okay. And this mixed field is generally defined as two distinct cell populations are present. So 2 distinct cell populations. So like if you had a transfusion and you're type O, and or like let's say you're type A and you got transfused with type O, you would show both A and O cells, or like AB.
Say that again on that 2 distinct cell populations.
Just a mixed field reaction. This one down here where you have a line at the top and some that went to the bottom. That's generally saying that you have 2 distinct cell populations present.
You're breaking up.
It just means that you have 2 distinct cell populations present, so that like you had mixed cells in there.
Okay.
And now the next notes are going to continue down, like we're at the same bullet that it would be at, like with gel filter.
Okay.
So this isn't part of gel filter, it's another like bullet point. Large agglutinates are trapped at the top. And so what reaction is that going to be? Your large agglutinates being trapped at the top.
Either a 3+ or 4+.
Correct. So that's going to be your, generally your 4+, and then your non-agglutinated cells travel to the bottom. So non-agglutinated cells travel to the bottom. And those are going to be what? What reaction? Lily?
Negative or 0, I guess.
Yeah. So that's going to be your negative or 0. Now, specifically in regards to your IAT, your indirect antiglobulin testing, what you do is you add the anti-sera, serum, or plasma. So anti-sera, serum, or plasma, and cells in the upper chamber. Oops. And then what happens is sensitized cells agglutinate by anti-IgG in the gel and cannot pass. So these would be for like your ABO and your D and all your other serologic testing. But if you're doing an IAT test of any sort, then you add your reagent and your patient or donor sample. And then the sensitized cells agglutinate by anti-IgG in the gel and cannot pass. And I think they actually make cards that have this anti-sera in it already, and then you add whatever your patient sample is. So I think that part works the same. You just have to have the card, the correct card that you need. Any gel tube questions?
No.
So what's the purpose of doing a reverse versus the other way?
Of doing a revert, like doing the gel versus the tube method, or like your so there's pros and cons to both of them. And what I've found is older techs tend to stick with the tube method, and then anyone learning tends to really like gel technology. So gel technology prevents you from having to put reagents in, and so I think that's always a wonderful help, because that is just one extra step that you aren't given the like option to mess up, you know? And so I think that's really awesome. But then you also have to have a special incubator, and you have to have a special centrifuge that holds the cassettes. And so there's pros and cons of each of them. But like I said, the older generations don't really like a whole lot of change, especially blood bank techs. I've told y'all are just, really, they like things done a certain way every time, because it's so important to not mess anything up. And if you know you did it the same way every time, then that you can say, definitively that you did it right every time. And so a lot of older techs don't really like change, and so they stick with the tube method. But I prefer the gel technology if it's available.
To me, it seems like it would be easier than the other way.
Yes, I think it's definitely easier, but there are people that prefer the tube method over the gel.
So you basically get the same reaction. One is it just bypasses a lot of steps versus the tubes.
Yes, and instead of having like your button at the bottom and having to look at them, you know, under a light and stuff, you just look at these reactions and know that if it's passed all the way to the bottom, that it's negative, and then the closer it is to the top is going to be more of your 4+. So the next one is going to be your microplate. And I have personally never seen this done in the lab, but I'm sure places use it and still cherish it. So what there is a 96 well micro titer, and that's a little plate. And so that replaces test tubes. So you don't have any test tubes. And then I actually like the picture for this better. And I think it pretty well explains everything you need to know about the microplate.
Now, when you say well, is this the thing where you have to put the holes in them, or?
I will show you. So this is what the microplate wells look like.
Oh, okay.
And sideways doesn't help you as much, but they're just pretty much little wells, like a water well. It's for, you know, miniature size.
Okay.
Okay, so your reactions of your microplate testing, a negative reaction well is going to look like this and like kind of swirl out. And then your positive reaction is going to have a solid button in the middle. And the terminology for that is a concentrated button of red blood cells. And then the negative will be a smooth suspension of red blood cells or a streaming pattern of red blood cells when the plate is placed on an angle. So do y'all know what that streaming pattern is? Like if you're swirling your tube and you see that little tail coming off, that's what
Right.
that's referring to.
Oh.
So the plate's not laid down flat, it's placed at an angle?
Well,
What
it's generally laid flat, and then when you turn it to an angle, you can see if that negative reaction is coming off in like a little tail, or
Oh,
if you're like, ooh, I don't know about that one, then you can look at it. When you tilt it, you should definitely be able to tell whether it's a negative or positive reaction. So like, just a moment, sorry. It might cut the video off in 10 minutes, so just a warning. I had it on the education version where it should keep going, so I don't know why that's coming up. So like here, if you're looking at one and you're not quite sure, like how, you know, this one's got like a little edge on it a little bit, or this one, how it's kind of oval. So when you tilt it, then you should be able to see, oh, well, that's, you know, negative. But also your negatives have like your hazy background, or more of a smooth colored background.
Mm-hmm. So for it to be positive, it has to be a full bullet, nothing
Yes.
dangling.
Correct.
All right.
And a clear background. So our last one is our solid phase. It uses a microplate wells with immobilized reagent. So it uses microplate wells with immobilized reagent, meaning the antigen or antibody is fixed to a microwell plate. So when in reference to antibody, the antibody is going to be fixed to the plate. And then you add the red blood cells. And what do the red blood cells have?
Antigens.
What is it?
Antigens.
Yep. So your red blood cells have antigens. So you add your red blood cells with antigens, and then a positive will adhere to the side of the plate. And I'll show you all a picture here in a minute. And then your antigens, they're going to be the ones that adhere. And do y'all know what adhere means? Like to stick?
Yeah. To stick to something.
Yes. And then so you add plasma. And what does plasma have? So like your red blood cells have antigen, your plasma has
Antibodies.
antibody. Yep. And then again, your positive will adhere to the side of the plate. And then you have to wash and add the check cells. And what that does is it attaches the antibody. And then your negative reactions will be a red blood cell pellet at the bottom of the plate. So is that the same as the microwell, or is it opposite?
The well, it'd be the same because they're both at the bottom.
But what's your positive versus your negative reactions? So over here, your positive is a concentrated button. So which one of these is going to be the concentrated button? So here, your negative reaction is your red blood cell pellet at the bottom of the plate. But in the microplate, the positive reaction is the button at the bottom.
So it'd be just the opposite.
Opposite, yeah, because they just couldn't make it easy, could they? So your gel is kind of opposite reactions of your tube system, and then your microplate is kind of opposite of your solid phase reactions. So here's an example of your solid phase testing. So here's your 4+, and then here's your negative. So I'll put this down here. So there's your microtiter plate. And I can send this to y'all. And that is all for our other methods. Any questions?
Can you make that chart a little bigger?
Yes. Let me go ahead and send it to you real quick.